Okay, welcome to lecture 6. Today I want to finish up sort of the visualization in chapter 3, which is section 3.3, and then actually we won't get to 3.2 until next time. The class at Stanford has a midterm exam, so we'll have to think about what that means for us. Probably that'll mean we won't have class Friday, July 27th, but I'll give you more details about that when we get closer to it. There's also another homework posted on the webpage if any of you are interested in doing that. It basically goes through the types of plots we've been making and gives you slightly different data sets, slightly bigger data sets too. Okay, so we were into chapter 3 last time. Again, chapter 3 starts off with the summary statistics in 3.2, but I'm doing the visualization first, which is 3.3, and I've argued that that makes sense to do it that way. When you first start looking at data, you probably want to begin by making some plots and then worry about summary statistics later, because oftentimes summary statistics don't mean anything if the data is all messed up, right? So what do I mean by all messed up? If half of the data, if the data is very bimodal, for example, the mean doesn't mean anything. If there's a lot of outliers, the variance doesn't mean anything, and the mean might be affected by those. So you pick those things up a lot more easily with visualization than you do with summary statistics, which is why I'm starting with the visualization. The one type of plot we didn't get to last time, which you can't really go through a basic stat class without seeing, so I should mention it, is what's called the box plot. It's funny, this is invented by Tukey, although there's another famous statistician from sort of the same time who's named George Box. So a lot of people often think that George Box invented the box plot, but in fact it's really called a box plot just because it has a box in it. Okay, so what's the box plot? Basically, you take some percentiles of interest, and usually it's the 25th percentile, the 50th percentile, and the 75th percentile. So you have basically the median, the first quartile, and the third quartile. You put a line at each one of them, and then you draw a box around it, and so then this box represents basically the middle 50% of the data. And then you sort of draw, these are sometimes called whiskers. The book says, if you look in the book on page 114, it says you draw them up to the 90th percentile and down to the 10th percentile. But it's more common that people will draw it up to the maximum and the minimum. But you do, in whatever you're doing, you do have to sort of not go if there's any outliers. You have to not include the outliers. Well, how do you determine if something's an outlier? Well, everyone has their own sort of pet method for determining outliers. Some of the most common methods are to sort of measure the interquartile range, basically this distance, and go up like 2 interquartile ranges either direction and draw some line and say anything above or below that's an outlier. Different people have different pet methods. You can read the documentation in R for what they use, but you have some threshold above which you consider something to be an outlier and below which you consider to be an outlier. And then you draw this line here at either the maximum or, as the book does, the 90th percentile. And these are useful. It gives you a nice simple summary distribution of the data. They're very useful for comparing distributions of multiple attributes or the same attribute for different groups. And if you do them in R, again, as I said, R doesn't do the 90th percentile and the 10th percentile. It does the maximum and the minimum, except for any outliers that it identifies. The one thing that I'll say about these, they're very useful for visualizing differences in medians relative to variation, right? Because the middle line is the median, so you want to sort of compare the median, which is the center value for each group, but you want to know how different those are relative to the variation in the data. And I think people don't really say this clearly, but this is why they're useful. And so the example I'll give you is sort of this not well posed question here, right? The median value of attribute A was 2.0 for men and 4.1 for women. Is this a big difference? Okay, so it's not a well-defined question. What does it mean to be a big difference? Are we talking about a practically big difference? Are we talking about a statistically significant difference? What are we talking about? Well, of course, it's not well-defined, and so the answer may depend on what you mean by big. But some people might view this as a ratio attribute, assume it's ratio, and say, well, yeah, sure, the women are twice as large as the men. Okay, that's one answer to it. Some people might take the statistically significant approach and say, well, give me a confidence interval for each one, but if you have millions of observations, then that doesn't really matter. But really, one other aspect of it is, how does the typical value for women compare to the distribution for men? Or how does the typical value for men compare to the distribution for women, right? Like, if this is the median value for men, 50% are above it, 50% are below it, how does that compare to the women, right? Is it sort of lower than the smallest woman? Is it lower than the 20th percentile for the women? How do the distributions line up? And so that's why the box plots are useful. And so if you see a picture like this, you see, oh my goodness, all of the men, the largest man is still smaller than the smallest smallest woman, right? So the distributions don't really overlap at all. So relative to the variation in the distributions, 2 is very different from 4.1. And depending on how much these boxes overlap, you might say something like, oh, you know, the 75th percentile for men could be equivalent to the 25th percentile for women, right? So it tells you to what extent the distributions overlap. So in this case, they don't overlap at all. So a value of 4.1 is much bigger than a value of 2.0 relative to the variation. Whereas over here, you see this value is still 2.0 and this is still 4.1. But, you know, the distributions are pretty much on top of each other. So maybe this isn't really a big difference. It still could be statistically significant. You know, it could still have some practical implications, but relative to the variation in the distributions, it's actually a small amount of change. So this is why box plots are useful. And sometimes what a lot of people do, they have a data set with a lot of numeric attributes. The first thing they do is just go and make box plots and line them up for all their numeric attributes that they want to compare to just sort of get a simple picture of the distribution of the data. So I'll demonstrate these for you with the data set you're used to, which is this exam scores and names. If I were to make a box plot for these, I could do it with the following commands in R. So again, this just reads in the data. And remember that the default here is header equal true, which is fine because that data has, what? I guess I didn't set my, yeah, but I thought I did. Let me try it again. Change directory, desktop. What's wrong with that? It's probably not on my desktop, right? Exams and names. Oh, I put the wrong one there. Okay, sorry. Where is exams and names? Here it is, that one. So you say, why don't I just set my working directory to be where it is? Well, I don't know. Okay, there we go. Okay, and then the command box plot will do the trick. And what am I plotting here? Well, let me first do it just to show you what the answer looks like. There you go. And then I'll go back to the slides here and say what I did. Basically, the second column in that data was exam 2. The third column was exam 3. So I make a box plot. I give it here 2 arguments. But unlike plot, you could give it 3 or 4 or 5 arguments, right? It would just make a box plot for each one of these groups. And of course, they don't have to be the same length, right? It's no problem at all. So you just give it as many arguments as you want box plots for. Color, you know, cosmetically, I think they're white by default. You put a title on it. You don't put an x-axis, but you put the labels. And this vector of labels, of course, is equal to the number of objects you're making box plots for. So these labels, exam 1 and exam 2, get plotted right down there. And then, of course, I put a y, label the y-axis to be exam score because it wouldn't be clear without that label what's going on there. So the default behavior in box plot is pretty good in R. I don't really feel the need to sort of change anything there. And then you get a nice box plot for those exam scores. And you see clearly that exam 2 is more difficult than exam 1 when you look at the box plot. We saw that when we looked at the empirical cumulative distribution function too. You know, but it's not like they don't overlap, right? I mean, this is the 50th percentile. It's sort of halfway between the 50th percentile here and the 25th percentile here. So that gives me a good feeling, a good measurement of how much the distributions overlap. And then the other thing that's interesting too is that R did label these 3 low guys as outliers on this exam based on the threshold. If you remember, these 3 people actually did pretty bad on exam 1, but they didn't do so bad that they got flagged as outliers here. Someone asked me the question once. They said, so once it determines the outliers, does it go back and recompute all the values? No, it doesn't. But if you think about all the values it's computing, those are all very robust to outliers, right? Things like the median wouldn't change at all, even if you map these guys into any other value above the median, right? It's still the median. The third quartile is still the same. So they usually use robust measures in the box plot. So it doesn't, it's good even if you have outliers in the data because those are robust measures, the quartiles are robust measures, and then you can sort of pick out the outliers based on that. So I think that's all I wanted to say about box plots. Again, it's sort of a very basic thing that you learn, but it can be useful. Okay, any questions about box plots? Question over there.
I didn't understand the box plot. What's the width?
The width is nothing. So it's a one-dimensional plot. And it's basically you're plotting 5 numbers. Min, Q1, Q2, Q3, max. Width is meaningless. Yeah, one-dimensional plot. Yeah, so you're like, yeah, but anyway, there's something that it's superfluous, right? Yeah. And I often thought like just a plot of like the 10 percentiles would be sort of more meaningful to me. But anyway, things evolve, and this is sort of something that sort of people like to make. Yeah. Okay, any other questions about the box plot? Yeah, it's simply a one-dimensional plot. The box is meaningless. But you know, as you get more and more, you can then just compress that dimension, and it doesn't really matter. Okay. So I was going to say, so up until now, we've done everything in R. Excel can also do a lot of these things. Of course, the obvious disadvantage to Excel is it doesn't handle large data. You can't really write scripts, so once you do everything you want to do, you can't really recreate it. However, if you're just sort of, someone sends you a CSV file, they say, hey, could you take a look at this data? Sometimes it is actually faster to sort of use the point and click interface in Excel to make some of these graphs. So I thought I would spend a few minutes just to mention to you how you can do some things in Excel. The one thing I will warn you about with Excel, and you can see people doing this all the time, if you're going to send around graphs made in Excel that anyone is going to see other than yourself, I really encourage you to change defaults, such as the Excel gray background or the yellow line or whatever weird things Excel does, because it does sort of look embarrassing if you're trying to show it to someone and they can see you just did this in Excel. And also, if I sort of have an internal classifier, right? When I see a plot that someone makes, the first thing that I sort of split on to determine whether or not this is a plot I should be looking at or something that could be meaningless is whether or not it was made in Excel with default values, right? If it's made in Excel with default values, there's a good chance that it's made by someone who's sort of just monkeying around and doesn't really know too much about what they're doing. The other thing I'll mention about Excel is that it has this nice feature called the pivot table. And if you've never used a pivot table in Excel before, you might find this interesting because it is sort of a very quick method for sort of making some nice tables that arguably would take you at least 10 minutes to write a script to do. So I'll show you that. So the first thing I just want to show you is, let's take a typical plot, right, like the scatter plot, and let's see how well Excel does with that. So I have these exam scores here, and let me see if I wanted to make a plot with these guys in Excel. Let's see, this was exams and names, right? So the one thing to be careful about with Excel, it has this weird convention where like the first row is often the column names. Some of the things in Excel want to have row headers in the first row, column headers in the first row. Some of them don't. And it turns out that the scatter plot is one that certainly doesn't. So, I mean, you could delete them. I'm just going to not highlight them. And so to make a scatter plot in Excel, it's as simple as insert, chart, and then it calls it XY scatter. And then the default one is the one I want. Usually in Excel, so it often tries to guess what you're doing, and it usually guesses wrong. The data range is usually synonymous with the Y values, and that's going to be useful here. So when it says data range, I'm going to give it the Y values, which is exam 2, because I want to put that on the Y axis. So I give it that for the Y values. Now it still hasn't made the right plot, but if I click on this series tab there, I see it has Y values populated, but the X values have not been populated. So all I have to do is give it the X values there, and then I should sort of get approximately what I want, and we'll talk about what it doesn't do right. So this is actually the right plot. It just doesn't look very good. It doesn't look at all as good as the one I made in R. And so what I want to talk about is how to fix this to make it look like a plot that if you actually wanted to show it to someone, you wouldn't be embarrassed to show them. So let's see, what can we fix here? Well, I guess the title is a little bit cosmetic, but I always say that it's good to include these because often what happens is your report doesn't get sent around, but your plot does. So it's good to sort of attach these to the plot. That's exam 1, that's exam 2. The legend here is completely useless if I only have one thing plotted there. So of course I'll get rid of the legend. The legends in Excel aren't as nice as the ones in R because they sort of live outside of the plot and sort of condense things too much. So I get rid of that. And then of course actually the rest of it I can do by pointing and clicking. So let me just sort of finish this one off. The other things that bother me about this plot are the fact that this one goes from 0 to 250 and this goes from 0 to 200. In R we actually made them both go from 0 to 200, or sorry, from 100 to 200. So I'm going to just go ahead and do that just like we did in R. That one goes 100 to 200. This one's going to go 100 to 200. The other thing that I mentioned is the gray background is really bad, so I'll just double click on that, change it to white. The points don't really need to be blue if there's only one color on there, it should be black, so I double click on the points and I can change these guys to be black, and I don't even need the default plotting symbol. I could make this one and make it a little bit smaller so it doesn't look so cartoonish. And then the other thing is these horizontal lines, right? I mean, arguably in this plot, X and Y are a bit interchangeable. So it seems like I should either have horizontal and vertical grid lines or neither. And I'm going to opt for neither. Now, the funny thing, and someone who knows Excel better might be able to tell me this, when I double click there, it doesn't let me pick none, but I can hack it, right, and just pick white. And because the points are on top, there's nothing is really lost there. So arguably, this plot, is not that embarrassing, right? I could send around this plot, and if you don't even look carefully, you might not even realize that I made it with Excel and not, sort of a real software package. So, I think the point is that Excel can make the plots for you, but you just have to go through a little bit of monkeying around to make it look a little bit more professional. And then the problem is, then once you've done that, and you need to change it, you don't have a script. You just have to remember sort of what sort of things you clicked on. But if you're just trying to, quickly, someone sends you some data, quickly make a plot of this, sometimes Excel or any spreadsheet application can be a good tool for doing that. So there's my XY plot, my scatter plot in Excel. Any questions about that or comments? Okay. So then the other thing I wanted to show you in Excel was the pivot table and the pivot chart report. This thing, how many people have used the pivot table in Excel before? A few of you have. So this thing is arguably, pretty useful sometimes if you're just trying to make a table with counts or averages or some summary statistics. I pulled out some more logs data from the Stats 202 logs. This has the web logs from May 7th to July 1st. And I'm going to sort of compare the counts for, let's just take lecture 2 and compare the PowerPoint to the PDF, because I actually originally just posted PowerPoint, and then one of the Stanford students said, could you please post these as PDF? And I thought, well, okay. But I was curious then to see, which is actually more popular. Are people downloading the PowerPoint or are they downloading the PDF? And I'm going to base this just on basically how many log entries there are, which is a little bit questionable, but still we can get a count. So suppose I want to make a table. Basically, I just want to have on the x-axis, the rows of the table would be the date, and the columns of the table, I'd have one column for the PowerPoint and one column for the PDF, and just give a count. So this is something that you can do with the pivot table in Excel. Let me let's see, I'm going to close this one and open the more, where is it? Here it goes, more Stats 202 logs. I'm going to open that with Microsoft Excel. Okay, and of course the first thing is it's all in one column. So again, I do text to columns delimited by a space. And that'll do the trick. Finish. Let's get rid of some of these columns that I don't really care about for this exercise. Let's see, probably don't care about these guys either right now. Okay, that's good enough. The one thing I'm going to need to use the date. Now, the real thing to do would be to sort of get this into a format where Excel actually recognizes it, that it's a date. That's sort of maybe more work than I want to do. What I am going to do, though, is at least split out the date from the timestamp. So to do that, let's see. So this is like date colon time. So let me insert a few columns here. That'll give me some columns. And let me split this column on the colon. So I'm going to do data text to columns, delimited, and split it on the colon. So that'll separate out the time from the date, right? So at least then I'll have a column that's sort of the date, even though Excel doesn't really have it formatted right. So then this is hours, minutes, seconds, right? But I'm actually not going to use that, so I'll just get rid of it. So I have the date here. This is May 7th, and then it goes to, I think I said July 1st or July 2nd. Okay, so that'll sort of work. The one thing about the pivot table in Excel, just like the XY scatter plot does not want column names, this one necessarily must have column names. So I need to put those in there, otherwise it just doesn't work, right? Otherwise I have to use the first observation as the column name, and it gets really confusing because it keeps referring to it like that. So, okay, so this is an IP address. This looks like the date. This is, I'm going to call this thing get. That's actually the column I'm interested in. This is some numeric code. This is some other numeric code. And this is the URL that they were on, right? So you can see sort of early in May, this was like davemease.com, but now later on stats202.com is much more popular because the classes started. Okay, so what does the pivot table do? So I go data, and I take pivot table and pivot chart report. Then you can actually read in other data sources when you do this, but I'm just going to do the data I have here. Click next. Where's the data you want to use? Well, it did guess correctly here, but basically I think they need to be contiguous columns, and each one has to have a name on it. Okay, then you're not finished, even though there's a checkered flag. You have to click layout, And then this is sort of the main interface here, right? Basically, you have your column names over here, and you just sort of drag things to the rows, drag things to the columns, and then do whatever you want in terms of aggregating that data. So in this case, I want to have date along the x-axis, and then on the y-axis, I want, date along in the rows, and on the columns, I want to put the get, right? Because I want to know, are they getting lecture2.powerpoint, or are they getting lecture2.pdf? And then you need something on the inside of the table, but if you're just counting, you can pick either one of these. They'll give you the same answer. And so I'll just put I'll put count of get. And it defaulted to count of get, but you can actually pick for numeric things like average, max, min, had get been numeric, those would have made sense. But because it's not, the count is really what makes sense, which is what it defaulted to here. And now if I say OK, see if this works, I actually wind up with a pretty big table, and on the x-axis it has all possible dates. Now because it doesn't know these are dates, they're not really put in the logical order. They're sort of put in alphabetical order, but that's not going to make a big difference. The column names here, basically I have a value for every possible thing that could have been got, right? Every possible value of get is up there, which isn't really what I wanted, right? I really just wanted to compare PowerPoint and PDF for lecture 2. So there's a nice way to do this. You just go up here to get, and see by default it's selected every possible value, but I can unselect that and simply pick which ones I want, which was the lecture 2, I said 1.1 PDF, and let's do 1.1 PowerPoint. Let's get those two guys. And once I say OK there, then I get, of course, a much smaller table with only 2 columns, the 2 columns that I asked for. And why fewer rows? Because it doesn't include the 0 rows. And if you know anything about the web page, lecture2.pdf and lecture2.powerpoint did not exist prior to June 27th. Okay. And so and then the logs stop after July 1st. So that's why I only have 5 rows in my data. And of course it's disturbing that they're out of order, but you can take this guy and sort of format it somewhere else if you want to fix that. So Control C, and then I'm just going to paste it somewhere else. Do we have any idea what that noise is? So do I press a button? Hit the green button? Hello? Well, it stops. Test. Yeah. This is the remixed version. Okay. I'm not going to touch that thing again. Okay. Well, I just saw that developers. Okay. So I'm just going to do a paste special and get the values and number formats of this thing. So basically it's the same table, but now you can sort of manipulate it. If you just paste the values, then you can sort of do whatever you want to sort of format it. And I don't know what, you might want to just sort of make it look a little better here. There's a version on the PowerPoint slides where I did that. I think the one thing that should be disturbing to you is that what happened to the counts for these things? They disappeared. Anyway, I have a version up on the PowerPoint slides I'll just show you where I sort of went through the formatting and I moved July to the last date. And then clearly you can see here that the PowerPoint is not as popular as the PDF, right? PDF is 777 total, PowerPoint is only 115 total. So the PDF looks like it's more popular. Now you could argue that, there's some of the crawlers are in there, right? Like you can see Yahoo's crawler in there, and you could say, well, maybe the crawlers are preferring to go for the PDF for some reason. Who knows what these crawlers are doing? But actually, if I have other reasons to believe that most of the behavior in these logs is due to actual users, and this would indicate that actual users are preferring to go to the PDF versus the PowerPoint. And then you can also see that it turns out the lecture 2 was on, I think, Thursday, June 28th. So it's interesting to note I posted it on Wednesday, June 27th, and so some people looked at it then, but of course a lot more people looked at it on Thursday, June 28th, which is when I had the class at Stanford, and then the class here at Google was Friday, June 29th, which is about just as many hits on that day and even more on the PowerPoint on that day. So it's sort of interesting to see, and then sort of it trails off on the weekend. People are still looking at it, but not quite as many. So you can see why, if someone gives you a CSV file with a bunch of data, you can do a few points and clicks and make a nice sort of table using the pivot table in Excel. Any questions on anything I did on that one? Okay, so the implication for me is that I continue to post the PDF version of the slides because they seem more popular. One other thing I wanted to do with that data while we're playing with the pivot table is I just want to look at basically the row counts in this data from May 7th to July 1st. I said to do it here just in May, but I'll do it for the whole time period if you want to see it. And it is interesting to see because stats202.com was not a very popular web page on May 7th, 2007, but it became a lot more popular on July, as we got closer to July 1st, 2007. And it's interesting to see sort of how the variation in it looks. And again, you can do that really easily with the pivot table. And let me, let's see, where do I want to do this? I think I can do it right here where I have the data. I want to make the date, and because I have 2 months here, I still need to split the date into day and month. And that's pretty easy to do. Again, I'm still not going to format it as a date, but I can at least separate the day from the month. And let me insert a couple more columns here. That should do it. And I'm going to do data, text to columns. I'm going to do delimited, and I'm going to tell it to split on the slash, just to break up my date. And that should do the trick. There we go. And I don't need 2007 because everything's in 2007. And the other thing that might bother you is that the date has that little bracket with it still. So just sort of fix that. I'm just going to say equals MID, which is like the substring command in Excel. This one, I want to take, starting with the second element, it's 1 based, and give me the two number of characters. And that'll change the bracket 07 to the 07. I double click there, populate that. So let's call this is the real date, and then this is the month. And then I can, actually I can't, okay, so I should show you what happens here. If I try and delete this, then that gives me an error, right? So you kind of want a static copy of that. So that's easy to do. Again, I just copy, and then I do edit paste special, and I get just the values of that. And then I'm free to delete both of these guys, right? Okay, there we go. So great, I have the day, which it's complaining that it's a number, it's stored as text, whatever. So that's actually day, I guess, day and month. Okay, so now I can do the pivot table. Now this is sort of just a one-dimensional pivot table, right? I just want to have basically the date along the side and nothing along the top, right? And so to do that, again, I do data, pivot table, and pivot chart report. Next, where's the data you want to use? It's here. Click layout. Now I'm going to put month first, and then day sort of nested within month. So that sort of will do the right thing. It'll go through the months, and for each month, and it will give me each day. And it doesn't really matter that I haven't told it that these things are dates because the months, May and June, are alphabetical, so it will default to that order. And then the days, actually, it's going to recognize that these are numeric, so it's going to sort of do those in order. So actually, that'll be fine. And then here, I just put like the count, right? This is just going to count the number of rows for each day. And so then I say OK, I say finish, and then here you have your counts, right? You see like May 7th, there were 88 lines in the logs. May 8th, there were 88, et cetera. We're sort of between, 0 and 200 all along through May. And then it's sort of interesting, right? June, we're still, between, 0 and 200, et cetera. And then something interesting happened on June 19th, where I got 1,922 hits in the logs. And if you remember, that's actually when I sent out the email saying, we're going to teach this data mining class here. And so I said, feel free to visit this URL, and then a lot of you did. And so there were 1,922 log entries for that date. Next day, not as many, not quite as many, not quite as many, not quite as many. And then you get another big spike on the 25th, which I think, and then even bigger on the 26th. The 26th was the first day of the class at Stanford. So that explains, I think, the big, is that right? The 26th was the first day, or was that, am I just making that up? June 26th, explain the data. Yeah, first day of Stanford class, okay. So that explains why you get the other big spike there. And then it sort of stays high after that because you have all the Stanford people and all the people. Actually, the 26th was not only the first day of class at Stanford, it was actually the first day of class here too. So that explains why you have high volume after that date. So, it's something you can see pretty quickly by making the pivot table. And of course, even better would be to make a plot of this. And let me at least make a plot. Actually, let's just plot the May data. That'll be pretty easy to do. The May data is not that interesting, but let me just show you how to make the plot. So I'm just going to copy this stuff and paste it somewhere else. Let's see, edit. Let's see. I want to paste special values in number formats. Actually, let's just go ahead and go all out and plot the June data too. No, I won't. Sorry. I don't know. I'll just plot the May data because it's sort of on the same scale. And let's see. Let me make a column that looks something like a real date. Oops. Don't do that. Just copy. There we go. And let me say this. So how do you concatenate strings in Excel? You actually just use the ampersand. And so what I want to do, I want to say equals this ampersand this ampersand this. So that'll say May-07. So that looks like a date, right? Okay. There we go. And so I want to basically plot this column on the x-axis, this column on the y-axis, and that'll give me a plot of basically the number of logs entries for each day in May. And so I can do insert chart line. Okay, insert chart line. Data range, again, that's usually the y values, which are these guys right there. And then it looks good, except the x-axis is not supposed to be those labels. So here I click on series, and it says category x-axis labels. And that are these values here, May 7th through May whatever, 31st. Ah, keeps running away. Who made this operating system? Okay. Let's see. Then we have that. And the other thing I don't like is the series tab. Let's see, legend, right? There's no need for a legend. If you had multiple lines, there would be. And then you can add some, titles. These are stats 202 logs. Oops, stats 202 logs. And this is the date, which you really don't need that because it's pretty obvious. But then you should say, like, what is this? Well, it's some count of the number of rows. So something that's loosely proportional to the amount of traffic, but arguably not a perfect measurement. And that looks good. Okay, and then of course you can do some of the sort of more cosmetic things, which is, make that white. You can change the color of the line, but it looks pretty good. And so I got ahead of myself on the slides here, but that was the table we made with the counts for May. And then this is that plot we made. And really nothing interesting is going on in May. I mean, I'm suspicious that this is maybe an artifact, although there may have been something that happened on that day, and this just looks like noise. But then if you go ahead and you make the plot for June, you can see those two spikes really big. The one spike where I sent the email to you guys about the class, then the other spike where this class actually started, and then after that it's not really a spike because it actually continues to be pretty high after that. So that just sort of shows you some of the things that you can do just by playing around with the pivot table and the plots in Excel. Should I hit green? See what happens. Hello. Okay. And again, why is this useful? It's useful if someone sends you a data set and says, look, take a quick look at this data set. Do you see anything? Before you sort of sit down and write a script to sort of do all this, you can probably figure out sort of some of the short answers in about 5 or 10 minutes by just sort of point and click with Excel. And then if you say, oh, something's really interesting here, then you can do a more formal investigation. But Excel is good for giving you some quick answers, or for that matter, sort of any spreadsheet application that gives you similar functionality. Okay. Is that all I was going to say about Excel? Yeah. Any questions about anything in Excel? Okay, so feel free to use Excel more or less depending on whether or not you think it would be a useful tool. So the last part of this, I just want to make some comments about different ideas that come up when you're trying to plot. So the one question is about color in plots. So in R you have this parameter COL, which can be useful for specifying color. Basically, if you were making a scatter plot, for example, you could give COL a vector equivalent to the length of which is equivalent to the number of points, and you can make each one a different color. That could be a function of some other numeric attribute. You could use it to sort of give you a third dimension on the plot. Color is nice, gives you a good way to differentiate. It makes the plots more interesting. However, there are some disadvantages, right? Some people.
Excuse me, the sound is not working in Kirkland.
Can Kirkland hear me now?
We still can't hear you in Kirkland.
You sure that you can't hear me?
Now I can hear you.
Okay. Okay. I'll try and speak towards this thing. Okay, so some disadvantages or some advantages of color. It's a nice way to differentiate and makes things more interesting to look at. Disadvantages, some people are colorblind. When you print things out, right, if you're writing a report or a journal article, it's usually going to be printed in black and white, and it can be distracting, right, and take away from what you're really trying to show. And then poor color schemes, right? You know, like Excel has this default sort of yellow that I think you only have to get into 5 or 6 groups before it starts making things in yellow. You know from here if you make dashboards or things like that, you know, and you want to have a new color for every group, but there's really only so many colors that can actually be differentiated from each other, and you wind up sort of saying, this is the blue line and this is the greenish blue line, and it gets sort of hard to look at. So there can be some disadvantages to using color. 3D plots, I thought I'd say a word about those. So they can sometimes be useful, especially if you're really trying to plot 3 numeric attributes at the same time. Sometimes you want to make a 3D scatter plot. There's a cute function in R for doing this. It's called scatterplot 3D. This is the first function I've shown you which is not in the base package. So when you use a function that's not in the base package, you have to do something like, well, this would work on my Windows machine, right? I just do install.packages, and it goes and it finds the different mirrors that are available, lets you pick one, and does all the installation yourself. You don't have to do anything. So let me sort of show you what would happen if I did that. So I already have it installed here, but I'll just show you what happens. If I say install.packages, immediately it says, please select a mirror. I would pick, you know, like USA, California, right, and do that, and then it would just sort of install everything for me, and I wouldn't have to worry. Installing packages on a Linux machine could be a little bit different depending on how things are set up. Sometimes you have to sort of save the files first in a temporary folder. But that'll work, and then once you have installed the package, you can say library that package. So I say library scatterplot 3D. That's just like, you know, reading libraries into, you know, Python or something like that. Now you have all the functionality that's associated with that. In particular, I have the scatterplot, sort of a long word, scatterplot 3D function, which works as you would think it works. It works sort of like plot, right? You give it X, Y, and now you also give it Z. And you can specify colors, the PCH, which you know I like 19, all these other arguments that are sort of logical to exactly what you would get for plot. And let's just sort of test it out to show you what it does. So if I can't, let's see, sequence 1 through 10, sequence 1 through 10, and then let me give it some uniform noise in the third dimension, right? So this would be X equal Y, and then Z is just random uniform noise. So, okay, I don't really see anything there. If I start to get more data, maybe I can see something. Let's see, Windows. Okay, so see, this is the thing. It's kind of hard for me to see. If you realize what's going on, right, all the data lives on the hyperplane and the diagonal. But it's really, you know, kind of hard to judge the perspective, and this is sort of one of the limitations to the scatter plot. I mean, this is an obvious relationship, right? Everything is on a hyperplane, and if you can't see this one, you know, I'm always suspicious of how much you can see. Now, of course, if you get enough data, if the relationship is really strong, you're going to start to see it. Whoops, well, I typed a slash instead of a, let's see, Windows. Okay, so it's pretty strong there, right? Now you can start to see it with 1,000 points. If I put, you know, 10 times more, then it'll be pretty clear. Windows, there you go. Perfect, right? So, you know, the question is like, is the 3D plot really going to show you some things? And if it's a strong relationship and you have enough data, maybe you can, but you might be better off sort of just making every possible, you know, the possible pairwise plots, or using, you know, color or something like the size of the points to represent the third dimension, because it is sort of hard to look at 3D plots, especially when you can't sort of have the ability to sort of rotate them and judge the perspective, because then you have to pick just the perfect angle, and that can be sort of a subtle game. So I think that's all I wanted to say about 3D plots, but if you do want to make one in R, the scatterplot 3D function is sort of a nice function that works. Any questions about 3D plots in R? Okay. The one thing you shouldn't do with 3D plots is use the third dimension in a manner that conveys no extra information just to make the plot look more impressive. So you're probably familiar with the canonical examples of this, right? There's the three-dimensional pie chart, and then there's sort of these three-dimensional like USA Today type plots. And so, you know, for the third dimension is providing nothing extra. It's, you know, people are just sort of trying to impress you, really, right? It's not giving you any extra information. So what is this? This is sales by region. Actually, I think I found this one by doing a query for 3D pie chart and this was on the first web page that came up. And then this one was from, sort of came around. This is number of Starbucks stores worldwide from 1987 until 2003. So the first thing, basically the third dimension is completely useless on these plots. The other thing to say, though, is that not only does the third dimension fail to provide any information in those examples, it can also distort the truth, right? So if you go back and you look, well, this one I think is the obvious one. You've probably seen this before, right? So how does this distort the truth? If I'm just making a simple bar chart or something, it's basically a one-dimensional plot, right? So if I had, in 1987, I had one Starbucks store. Okay, it's one. And suppose in, whatever the next year is, I had two Starbucks stores, two, right? So this thing is twice as big as this thing. Okay, no problem, right? It's a one-dimensional, right? I scale it in one dimension. However, right, if you do, like this, right? And now this is too tall and too wide. This thing is, of course, 4 times as big as this. In fact, if this were like the unit square, right, this would still have volume 1, but this thing could have volume 8, right? So now there's like 8 times as many Starbucks stores, or at least it looks that way, right? Because if you change all the dimensions at the same time, and that's really what they're doing here, right? They have the Y scale, and the things are getting higher according to the Y scale, but at the same time they're also getting fatter. So it's actually, you're actually lying, right? There's actually not this many more Starbucks stores. You're just trying to make it look that way. So you're tricking people. So that's sort of the story there. The story on this one is more subtle. But it's been alleged that the following is true. And I always wanted to do an experiment to try and confirm this. Depending on how you rotate the three-dimensional pie chart, you can make certain areas look bigger or smaller. So for example, if the yellow were in the back, arguably it would look smaller. And I think there's an obvious experiment you could do to test this out, and I've always wanted to do it. But I believe it's true, right? In fact, you might even say here, this one looks smaller than this one, even though this one is 15 and that one is 17, because the gray one is in the back. So not only does it not do anything extra, not only are you not really impressing people even though you're trying to, you can also be sort of misleading and lying and tricking them. Okay. Any questions, comments, real-life experience with that? Yeah.
With the pie chart, the usual interpretation in kind of visual science is that your brain imputes a perspective onto it, which wasn't there in the design. So the ones in the back often look bigger to you because you're thinking it's farther away. Your brain is just programmed to see that.
So you're saying they don't include the perspective and then you include it so the ones in the back look bigger.
They could choose to include perspective, but generally it's not done that way.
Interesting.
Your brain tends to project.
So the angles are true and then your brain puts the perspective. Interesting.
So question mark pi in R gives you good bibliographical references as to why you should never use it.
Oh, really? There's some good documentation on it in R.
Color may be actually what's misleading here, because red strikes out at you and gray kind of fades and hides.
Right. Yeah, so the color
It's not just
color
the
is
3D,
also,
the colors may be blind.
yeah, the color can also be misleading on this one. Yeah, and for those of you who didn't hear the comment, I guess you say question mark pi in R will give you some good references to why you shouldn't make the 3D pie charts. Or any pie chart, for that matter. I didn't make any pie charts. We won't make any pie charts. Okay, so that's what we want to say about 3D plots. So in the book, they have these accent principles, which is a little obnoxious because accent is an acronym, but they also mention Tufte's guidelines, and he has some good guidelines in there, and I won't take the time to read through them, but you should take a peek on page 130 in the text, and he has some good rules for presenting data, because the main thing is, the presentation of the data is meant to take something that's complex and simplify it and convey as much information as possible with as little ink and as little confusion as possible. And I think, wasn't Tufte the one that talked about the ink to information ratio? Yeah, so it's the most information with the smallest amount of ink. I mean, you've probably seen the situation where someone has a simple story to tell and they're telling it with a complex graph, and that's the opposite of what you're trying to do, right? Okay, here's a few cute examples from sort of an old textbook I had. So the bad one, right? Sales were low every quarter last year. Well, low relative to what? Low relative to the arbitrary value of 200 that you've chosen to scale your y-axis by, right? So in fact, you always sort of scale according to the maximum and the minimum, and so, sales last quarter or last year were fine, and we now notice that Q3 is actually a pretty strong quarter. this is sort of the typical one. Now you always see this when you sort of query your stock symbol and you get your stock ticker and, oh no, the stock bottomed out today. But the bottom, right, just happens to be the lowest number on the graph. So it looks like, April was a horrible month and it hit rock bottom. But it didn't hit rock bottom, it just hit 36. And one of the months is always going to be at the bottom if you're going to scale according to that. So a common recommendation is that you should either start at 0, especially for things that are ratio valued, and then you realize April wasn't really that bad, or you put some little hash mark there. Now, of course, this isn't always practical because this graph does lose a lot of the resolution, right? You don't always just want to have, the 0 point there. So you need some way to sort of balance this. Like you want to have high resolution, but you don't want to trick people to make it think it's really that bad and always be rescaling it. So this is not really an easy answer to this. It's a huge challenge, especially if you're making dashboards that continuously plot graphs. One solution to it I've heard is that people will say, well, let me sort of, put horizontal lines at a fixed width and never change that width. And then when I rescale or zoom in, people will know based on how many lines they see. But there's no good solution to it. But you do have to be careful that if you're going to rescale graphs based on the minimum and the maximum value on the graph and not having the 0 on the y-axis, you can sort of mislead people by making them think that the smallest value is really small when in fact, it's actually quite constant if you plot it with the 0 there. So, yes?
Is there an easy way in R or Excel to give that break indication? Or?
I know in R, you can actually just, probably put some line there. Excel, I don't think that I know of an easy way. This isn't actually that standard, but, it does help to sort of let people know that, look, that's not 0, right? That's not the bottom. Yeah. Okay, the next one here, there's nothing really wrong with the graph, right? But it's just the question is what information are you trying to convey? And here I've counted the number of freshmen, sophomores, juniors, and seniors who got A's, right? And so it looks like, well, a lot of freshmen got A's, right? More freshmen got A's than sophomores. But you're really, of course, not interested in the absolute number of freshmen that got A's. You're interested in the relative number of freshmen that got A's. Now, you might naively assume that it should be the same, but what if it's a class, that's dominated by freshmen? So what you really want to see, of course, is the relative values. And so nothing wrong with the graph. It's just this isn't the right information to convey, the frequency. You want to compare the relative frequency or the percentage. So the same number of people got A's relative to the total, right? So you don't want to mislead people that way. And then, of course, this is the last one I have. This is a lot of things are wrong here, right? First of all, you don't really need the animation. I don't need a movie of a minimum wage job to tell you about the minimum wage, right? So that's sort of the first problem. The second problem is sort of this 3D effect, right? That if I took this $1 bill and put it inside this $1 bill, more than 3.8 of them would fit, right? This $1 bill is more than 3.8 times as big as that one. And why is it? Well, of course, if they scaled the length by 3.8 and didn't scale the height, then George Washington's face would be really stretched out and distorted. So they have to scale the height. Well, then, you get into this two-dimensional problem, right? So the point is you probably shouldn't use your picture, and change the size of your picture. You could probably just use like a bar, a bar chart would be sufficient, or even better, we're tracking something over time, so probably something like this would work well to convey the same information without all this sort of, they call it chart junk and animation and distorting the truth, right? Because, it's only 4 times as big. It's not, that many times as big. So you're being sort of tricky at the same time as being distracting and putting too much animation there. Okay, so the last thing I wanted to say about graphing is if you go through sort of any journal, well, I can speak for statistics anyways, and you look at the plots that get published in the journal, you can have a lot of fun, sort of making fun of your colleagues, right? Because you can pretty much figure out what software package they use to make the plots because they never change the default values for the font size, for the font type, for the color schemes, for the margin size, for the plotting characters, etc. Right? It's always people just use the defaults. And of course, you're not really, there's no reason to, right? You're not going to convey any extra information, but it certainly would look a lot better. And so in R, if you go the function PAR, you can actually control a lot of these. And when it shows up a lot, like a lot of times the font on the plot is like 1/4 the size of the plot in the article. or much bigger, right? It just doesn't match at all. And now you don't always know until the copy editor shows you, how they're going to position the plot on the page and how big it's going to be. But you want to match. Other things that I see a lot in stat journals, people will write the word alpha instead of putting in alpha. Now, you can put alpha in the labels of the plot. People just, I don't know, they don't know how to do it, or they're too lazy, or they just want to write the word alpha. But all through the article, it's a Greek letter alpha. Then all of a sudden on the plot, it says the word alpha, right? Same thing with subscripts. They'll just put _1. Whereas this expression here, I'll just show you if you don't believe me. This will do the trick, right? So what they'll do is they'll say plot, let's plot 1 point. And then they'll say x label equals alpha _1. Whereas through the whole paper, it's a Greek letter alpha with a subscript. But on their plot, somehow it shows up like alpha _1, right? And all you really need to do is to do this, right? There's a command called expression that will do the trick for you. X label equals expression alpha 1. You get sort of a nice looking alpha with sort of a nice looking subscript 1. Okay? Not, maybe not the exact same font type as the journal article used, but at least it's an alpha and at least it's a subscript. Okay? Other things that they mess up, the distance between here and here. You may want it to be bigger or smaller. The distance between here and here. The font size of these things. Which one of these things are appearing? The distance between here and here, the distance between here and here. If you stack up multiple plots, sometimes you can't tell if this one is going with this one or the one below it. So all these things, if you look through journals, typically people are pretty lazy about. And so if you just read through like the documentation on PAR, you will come away with the following conclusion. You will come away with the conclusion that you can change anything you want, and it's probably some 3-letter string that has no meaning, but it's documented here, right? Because they just start out ADJ, ANN, ASK, BG, BTY, CEX, 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 COL, CIN. Like all these things control something. And it's, if you're going to make plots using R, at some point you might want to read through all this documentation and see, MAI, numerical vector of the form, which gives the margin size specified in inches. MAR, numerical of the form, which gives the number of lines of margin to be specified. MEX, a character expansion, which is used to describe the coordinates of the margin of the plots, does not change the font size, rather specifies the font. Okay, so there's all these things that you can change. You just sort of have to have some patience, to go through and do it. And what I'm complaining about is a lot of people don't. Now in Excel, you are kind of stuck, right? You see these weird things in Excel where the tick marks don't line up with the actual values and things like that. But you can usually improve upon the default by just sort of having some patience with it. So I think that's all I wanted to say about plotting. Next time we'll talk about some basic summary statistics, but I think I'll stop there today. Do you guys have any questions about anything before we take off? Okay, have a good weekend. I'll see you Tuesday.